$50 away from 1,500. That's where that answer comes from. Now, Nick says, let's do 11. Why not? Generally, if you could keep me on the same page, I would greatly appreciate that, just because I have a feeling we're going to do most of these. Oh boy.
I think we just start at 1 and go all the way.
It's true.
Well, just like saying
could-
whoever top.
We could start with, sorry, if you're watching this at home, I have to recalibrate it.
You could just say whoever's top or question.
I fear we'll do probably all but maybe one. Okay, there we go. The value of a car declines 20% every year. What's the percent of the original value remains after 2 years? The best way I can tell you to do this, basically would be this. You're not given the value of the car, right, Nick? By the way, did I help somebody with this? Did I get the right answer?
Yeah.
Okay, let's let them do that first. Here's what I would do, okay? First of all, this. I would wait till the end, to do the, little table, okay? We don't know what our ending numbers are gonna be because there's no numbers given. So I would just put in a number that I would do. For example, 100. Nice easy number. If the car started out being $100, okay, and it declined 20% the first year, how much would the car cost? Well, find out what 20% of 100 is, which happens to be $20. Okay, so now how much is the car worth? It's only worth $80 because it declined 20, right? That's after the first year. Well, if it declines 20% the second year, how much is 20% of 18? Or 80? 16. So I take 60 away from 80 and I get 64. Okay, so my car started out being $100. 2 years later, it ended up being $64, right? So if I'm filling in my little box on percent decrease, I feel my thinker. Okay, well here's my 100%. This is my percents. I don't know either of these two because I'm filling in those blanks, but I do know my car started out costing $100, ended up being $64. So that means it went down $36. Now the question is, which of these two percentages do they want? They want what percent of the original remains after 2 years. So they want this. What percent would that be? So when you write it out, it looks like 100 over what number equals 100 over 64. And I don't know why this thing is. Any suggestions on what I could do to get this to work better? So what will this be? 100 times what is 100? Times 1. 64 times what? 1 is, and that's where your 64% comes from. Because it went down. So you just have to decrease it that many times. Is there another way to do it? I'm sure there is, but this is probably like the only make a little table and get it to go down.
So just have to make up your own digits.
Right, and I would use 100 just because it's an easy number. Plus it gives you the 100 over here that you don't have to worry about. 1,000 probably would be a good number to work with. Just something very easy. 10 would probably done the same thing, except I would have gotten 6.4 probably there or something, $6.40. Much for a car. Maybe it's because I'm zoomed in so much. Jackson?
For number 11, how do you get 64? You did 80 times 20.
I took, it reduced by 20%, so I took 20% of 80, which was $16. That's how much it was reduced. So if I take $16 away from 80, that's where the 64 came from. That's how much my car would be worth after 2 years, so like $64. I went down 20% the first year, went from 100 down to 80, then it went down 20% the second year, which means it went down from 80 down to $64. Okay. Nick, thank you. See now, tomorrow's test, kids, if you have this all written down on your paper, it's going to be the same thing, except they're probably going to say it declined 30%. So to me, you don't even have to understand why. You just say, okay, the steps he did here was he found 30% of that number, got an answer, found 30% of that number, got an answer, and then really whatever that thing is happened to be the answer to the problem. as long as you use 100, it's probably going to end up that way. John. Brandon Norman. Wait, did you ask a question, Nick? Did I just skip over what you just said? Okay, I like that. Well, you can't do number 10 unless you get number 9 right. But I will tell you how to start number 10. The first thing is this, okay? You are talking about scales. If you go from 1 to 10, what is your scale factor? What do you multiply 1 by to get 10? Okay, so my scale factor is 10. Okay? Now, if my scale factor is 10, if I'm looking for the area, how much bigger the area gets, it's the scale factor squared, which happens to be 100 times bigger. Keep this thing down. If I'm looking for my volume, volume is always the scale factor cubed. So that is 1,000 times bigger. What if I shrink this or something would be better or something? I'm just getting tired of it not working very well. Let's try that. Well, you can't see much probably with that. Okay, so here's the deal with problem number 10. Okay, to go from the model, great. To go from the model, if you have a model of something, and then you have the real thing, you have to multiply the volume, since we're talking about volume, by 1,000 on the little one to get to the big one. So I need to know what the volume is from problem number 8. Okay, and what is the volume from problem number 8? Did you get the volume right there, or do I need to do problem number 8? You get it right? Alright, so if you're looking at this shape right here, how do you find the volume of that shape? It is basically what? What's my formula for finding the volume of somebody, the volume of any prism?
9 times.
No, that's a rectangular prism. Probably the quickest way to do this, the volume of this shape is equal to the area of the base times its height. I should just start this whole thing over again. And remember the whole loaf of bread thing. What's the base of this thing? If this was a loaf of bread and you sliced it, you got equal pieces, what shape is that going to be? Huh? It's going to be this. It's actually a pentagon. It's going to be this. This is the base right here. How high is it then if that's the base? If you set it on its base, it's going to be how high? No. If you set it on top of its face, if you set it on that front door, it's going to be 30 feet high. Okay, as you cut that loaf of bread, you're going to get 30 whatever is deep. So you know your height is 30. I just need to multiply 30 by what is the area of this shape right here. Well, you have to cut it into two little shapes here. The rectangle is 20 times 10. The rectangle is 200. What's the little triangle that makes the top? Here's my little triangle that makes the top. It is 5 high by 20 wide. 1/2 base times height is 5 times 20 is 100. So this little triangular piece is 50. So 50 plus 200 is, the area of the base is 250. I multiply the area of the base times the height, and I get my total volume, which is 7,500. All days. So that's your answer for letter 8. It's 7,500 cubic feet. And then to answer question number 10, okay, is this the scale drawing or is this the real thing? It's the real thing. Okay, you're not going to make a scale that's 20 feet wide or whatever. So my real thing was 7,500. they want to know for problem number 10, what would be the volume of the scale? Well, if I multiply this by 1,000 to get to that, if I know that, then I have to divide by 1,000 to get this. So you just move the decimal back 3 places, and that's where 7.5 comes from. Because you're dividing by, because this is the model. You started with the big thing, went down to the model.
I'm sorry about that.
Life is hard all over, as they like to say. Jackson.
This is number 8, like, so how do you get to 100?
Here we go, Jackson. I am going to, sorry, let me do a little zoom full. Let's see if this works a little better. Here we go. Sorry. Here is your shape, right? It was this house-looking shape. This was 20, this was 30, this was 10, and to the peak from the bottom was 15. Okay? The rest of it, the pictures and all that stuff don't matter. Okay? If I am looking for the volume of this thing, it is the area of the base times the height of the shape. And the height is always perpendicular to the base. Okay, do you understand why this is the base? If it's a loaf of bread, how are you going to slice it so you're always going to get the same shape? If I sliced it like this, I'd get rectangles up to here, but then when I kept slicing it here, I'm going to keep getting small and small until I get nothing there. If I slice it like this, you're always going to get different shapes. If you cut it like this, you're always going to get, this is the base, right there. Right on? You set it on its base, that's the height. So even though this 30 looks like it's a width or something like that, no it's not, because this, if you put it on its base and you cut it like this dimension there is how high it's going to be. So the problem maybe is in you finding out what the area of this is. Let's just do that. Again, it's really not that hard. Okay, I have to cut it into a rectangle and a triangle. This rectangle is 10 by 20, it's 200. And then this triangle here is 20 by, how high is it? 15 goes from here, 15 goes all the way from down here, so you have to take the 10 away, it's 5 high. So 20 times 5 is 100, cut in half is 50. So I have to put these two together to get my whole area there, that is 250. And I multiply 250 times 30, that's where 7,500 comes from. Got this? Okay.
But you only found half of the front of the top corner. Because there's another way through.
No, I found the whole thing because I used 20, my whole base. If I had just used 10, I'd only found half. But this is the whole thing with the whole base. Good point. I see what that means. Sage?
For finding the height of the triangle on the inside, can you just like take the 10 and just cut that in half?
What 10? I
The
don't see a 10.
layer.
This 10?
Yeah.
No, this 5 came from this whole 15 minus the 10 that was this part right here. So this part had to be 5. 10 plus 5 gives you that whole 15. Didn't have anything to do with this 10, other than you subtract that 10. I don't know what number that is. Go back. Number 9. Is this 9? I wish this thing was working. Of all the days. Find the area of the exterior lateral surface of the barn, which excludes the area of the roof and the floor. So back to my barn. Let's do that. Back to this thing here. They said find the, why didn't it go? Can I tell you this thing is starting to? I'm going to know that. So if I got this shape and I want to find the lateral surface area, basically the lateral surface area is no more than this shape, which I already found the area of, which is good. There's two of those. There's a front and a back of those. And then there's just this rectangle and its rectangle on the other side. If you were painting this building, you don't paint the roof, and you're not painting the floor, painting the outside of this building, what would you paint? You'd paint this you paint this and the same things on the back and the other side. So we already found one of them. You've got the 250 for the front and back. The only thing you have to add is this side and its same other side over there, which is 10 times 30, 300. And that's where you get 1100 of them. Okay, because you don't paint the rough lines, you don't paint the floor, you just paint the four sides. And I'm sure you're asking, is that what tomorrow is? I don't know, I'm not looking at it. I probably should look at it. Give you some helpful hints. I don't think they'll change it. Lauren,
I don't get number 7B.
70.
7B.
Did you say 7B? 7B. Oh, 7's going to be an easy one too.
I didn't really understand what it is.
Some people didn't understand any of 7, so we'll just go with that. When you charge something to a credit card, okay, they don't just give you that money for free, you have to pay interest. And on this credit card, it is 1.5% per month. Okay? 1.5 per month. So how much interest do you have to pay to borrow that money for 1 month? It is $1,500. Now here's where most people that I saw went wrong in changing. You have to change 1.5% to a decimal. You don't multiply by 1.5 because that's 150%. Okay? You need to make this 0.015. That is the decimal that 1.5% is. Now to stop a bunch of waste of time, that ended up being $22.50. Okay? That is, ladies and gentlemen, how much interest you had to pay for borrowing that money. Okay? Most credit cards tell you you have to pay a minimum balance, a minimum of something. Okay, and in this case it was $30. So if you paid just $30, if you paid $30, they're going to take the interest part of that. You paid $22.50 in interest. Okay, if you do that, that means what's left over actually gets put towards reducing this part of the bill. Okay, and that's what letter B asks you. Okay, you pay $22.50 in interest. You gave them $30, so there's leftover, and that leftover reduces this $1,500. You just subtract $1,500. I don't know why this is working. Minus $7.50. You're going to get $1,420. Wait, what did I say? $1,492.50. And that's where letter B comes from. And if you ask yourself this question, if you just take off $7 every month, how many months is it going to take you to pay off $1,500? 200 months, which is how many years?
A lot.
And if there's 12 months in a year, 8 is 100. It's going to take you 16 years at $30 a month. Okay? And what's $30 a month is $360, 16 times. You're going to end up paying like $4,000 or $5,000 in interest on $1,500 by that time that's all said and done. And the difference between credit cards and like when you get interest on houses, okay, credit cards charge you so much per month, whereas houses is more per year. And that's kind of what people get wrong. Because you think 1.5% interest isn't that much, but that's per month. Houses, when you pay 3% interest on a housing loan, that means 3% a year. That's spread over 12 months. This is spread over 1 month, and that's kind of a lot of money. Nick?
You still have to pay interest even if you make the payments?
No. If you pay it off, you're done. I mean, if I paid them $1,500, I don't pay it for interest. I don't pay any interest on anything. And that's why you have to be very disciplined there. Brandon Norman. Which one?
13. How would you like your 16 and 250?
I would look on my reference sheet. Do you not have the reference sheet? Yes.
Oh,
That little sheet should have 16 and 2/3%.
yeah.
Otherwise, do you have a way of actually doing this? You do now. Because what does this change to as a decimal? 0.16 repeater, and since you now know how to change repeating decimals to fractions, you could do it that way, change it to a fraction, then multiply the fraction by that. But you can't just, yeah, you know, you could, no you can't. Yes you could, no you couldn't. Yeah, that would be the best thing, just look at your little sheet there. Same thing for 5/9. Yes, Lauren?
So can we use like our little
Yes,
sheet?
use your little sheet, by all means. Should I look and see if tomorrow's is gonna actually be something on your little sheet?
Yeah.
You're scared, aren't you? I don't know, I'm gonna look here. Let me look. You should be scared. I'm scared for you, not that I'm taking the test.
It's probably gonna be like 66.
Let me look. Maybe sometimes you get the same one, not usually. What problem is it? 13. Oh yeah, I think you'll have no problem with that one. What's that? I would look on my sheet and change it to what fraction is 16 2/4 from here? So you're just gonna take 1/6 of 1296. So really all you're doing is dividing 6 into 1296. Just dividing 6 into 1296, which ends up being what? 2.16, $2.16. So far so good, John and I are.
Okay, so I'm number 3.
How did I? Or why did I do that? I did number 3 because it was part of it. Oh yes, number 3. Here are the notes you need for number 3. Write these down, children. It's a long progression of things. Let me make sure before I go into this. Yes. Tomorrow's letter B is pretty much the same, just different numbers. First of all, you need to know that 1 cubic centimeter is the same thing as 1 gram. 1 cubic centimeter of water weighs 1 gram in weight. You're changing really volume into mass. Okay? You need to know that there are 1,000 grams in a kilogram. Oh boy. The problem tells you that there are 2.2 pounds in 1 kilogram. Do I need to know something else? I think that's all I need to know. Okay, so jot those down on your notes and then we'll talk. I'm actually going to go back here and reduce my screen so my thing doesn't work so terribly. So here's the deal. They give you, what is it, 20 by 20? 30 by 30? What's the cube? 30. They give you a 30 by 30 by 30 cube. Right? And they ask you how much this will be in pounds. How much would it weigh? So the first thing you want to do is find its volume. And it's a cube, so you can just do 30 times 30 times 30. Length times width times height. And again, hopefully this isn't hard for you. It's 3 times 3 times 3, which is 27 plus 1, 2, 3 zeros. 27,000 cubic centimeters. That's how many cubic centimeters you have. Okay? Now you need to change cubic centimeters into grams. And that's a very easy look. It's 27,000 centimeters cubed over 1. I'm changing centimeters cubed into grams. And what was my conversion? It's 1 for 1. So 27,000 centimeters cubed is how many grams? 1 times 20, yeah. There's no, it's exactly the same. Now I need to take 27,000 grams and change it into kilograms. So I put it over 1, multiplied by grams on the bottom, kilograms on the top. How many grams are in a kilogram? 1,000. So if I take 27,000 and divide it by 1,000, I end up with, this thing weighs 27 kilograms. Now I need to use that 2.2 thing and change 27 kilograms into pounds. And I know there are 2.2 kilograms or pounds equals 1 kilogram. So then it's just a matter of taking 27 times 2.2, which is 54 and, I'm sorry, 54, yeah. 59.4 pounds. Just a lot of conversions. Tomorrow will be exactly the same, just with some different numbers. Now you could skip this step here because you know this part here is just kind of goofy, but it is what it is. That you just divide it out there. And that's probably accurate. Eighth, how big is 30 centimeters? Who's got a ruler? Somebody hold the ruler right there. A ruler is about 30 centimeters, isn't it?
Yeah, exactly.
And that sounds like a lot to me. What's that? Yeah, this is 30 centimeters right here. Do you realize and that's true. A cube that's this size of a ruler, in other words, the size of a floor tile that's a foot high, that would weigh 57 pounds, or 60 pounds of water there, 60 pounds.
Are you done teaching?
We will never be done teaching, so if you want to go right
Are they done
now,
learning?
well, they were done learning a while ago, but let's do it now because they need a mental break from what we're doing.
I just need like 2 a